Okay, so potable water means it's safe to drink, and if it had impurities, then and you're drinking it, therefore they must be harmless for consumption. The process to make water safe goes through three stages, and it wants to know what is meant by sedimentation. Sedimentation is where you allow um, the impurities to settle, so any solid bits to settle to the bottom of the container. So that's going to be option C. State why wastewater is filtered. So that is to remove insoluble substances. Chlorination is because chlorination kills bacteria. Then we've got a little graph, and the graph shows you what is happening to the amount of salt added and the removal of the impurities based on the salt. And we've got two salts, salt A and salt B. I've added some lines which I'll explain in a moment to you. The first thing it says here is that they said the best way to purify the water is to add 100 milligrams of salt B. Use the graph to explain if this is good. So first of all, 100 milligrams of salt B. So if we go to salt B and go for 100 milligrams, you can see that that's meeting that graph here. And therefore, we're removing more impurities with 100 grams of B than we remove with 100 grams of A. So that would be a good thing to do because that would be more cost effective, and it also means you need less of chemical B in order to do that. So you can argue that B is better, as your conclusion states, because it removes more impurities than A when 100 milligrams is added, and therefore you need less of B required to be that effective. You could also argue that A is better because if you add 150 micrograms of A, then you are milligrams of A, you are then removing more impurities than 100 milligrams of B. So that's another argument you can say. You can say A is better because 150 removes more impurities than B. Either one can be correct. It's just how you present your argument that's going to get you the marks. Okay, next one is a long answer. And again, I've already written this to go through it with you so you can see what we need to do. But it tells us we've got this sample of water contaminated with a dissolved solid. Say how you would get water from the mixture, including how you'd show that the water is neutral. Okay, so we've got this equipment set up. So the first thing I would do is to draw this out. So we're drawing out here the distillation. And if we say distillation, we're going to get a mark in this answer. So we've got our flask. In this, you could use the conical flask instead if you wanted to, and then you'd have your test tube under here, but we use a round bottom in class, so I've drawn it that way. Okay, this is where our water with our dissolved solid is, and once we've set this all up, we're going to heat this, so heat the flask. The water will evaporate and the water will rise up through the flask. Once it's hot enough, this thermometer here will read 100 degrees because that's the temperature water boils at. And the gas is then travelling into the condenser. The condenser is surrounded by cold water. So as the hot gas comes into it, the gas is cooled, it condenses, forms a liquid. The liquid is then emerges from the bottom here and can be collected as distillate. So in terms of the points explaining that, we've got set it up as shown, heat the flask, the water evaporates and it will rise, and that will happen at 100 degrees. That will be the reading on the thermometer. The water vapor enters the condenser where it is cooled. It will then condense to form pure water, and this will mean that the solid will be left behind in the flask where we're heating. Testing the water to prove it's neutral, we could use a pH probe, or we could have a universal indicator, and if you're going to use universal indicator, you just add a few drops, and you would add a few drops, we put the probe in, and the pH would either be 7 on the probe, or the indicator would turn green to show that it is neutral. If you include the little red points I've got here as well, alongside the bullet points, there are 12 points in total that we need to be talking about. And again, if you've got 10 or more, we're giving you 6, and 9 or 8 points is 5, and so on and so on and so on. So use that scale to work out how many points you got for that answer.